What we have on the bench today looks pretty ugly and boring, but it is the antenna amplifier for our UHF repeater here in our area. And well, this antenna amplifier should have a gain of about 10 dB, and it is at the input of the repeater, so it will amplify all the incoming signals to the repeater, and therefore this is very important. And in the last time we have recognized that the input signals to the repeaters are getting low, and that all the mobile stations who are on its way are recognizing that they still hearing the repeater, but they are not able to talk to a distant end. And well, that is because we need amplified signal in the receiver or input antenna line, that you know, it is balanced, the level between RX of the mobile stations and the TX of you know, the repeater, because okay, yeah, the repeater transmit is always stronger, so you know, you need to find a balance somewhere, and that is the reason why this antenna amplifier is in line. And well, okay, so our to do is to check if this antenna amplifier is still working on the repeater frequency. So okay, the first test we can perform is when we put the amplifier to the power supply to 13.87 volt, whatever, do we have a short or do we have a power consumption? And if we read a power consumption without any short, then we can presume that the amplifier is working. So yeah, plus is already connected to this wire here, and now I put ground to the system, and what we can see, it is 20 milliamps what the amplifier is drawing, and I double check it here on the meter. So exactly, it is exactly 19.57 milliamps. So ground taken away, so there is no current drawn, which is normal. And yeah, connected, ground connected, we see a reading of 19, approximately 20 milliamps, which this antenna amplifier is drawing. So yeah, we can expect that obviously the amplifier is working. So the operator of the repeater told me that this is not a wideband amplifier. He said that there is a band pass inside which will only let the frequency of 431. I guess I have to double check it, but anyway, 431 megahertz should pass through, and this frequency should get an amplification of about 10 dB. So that will be the next to check. Okay, so the first test we are performing is the amplifier is connected at the input with our signal gen on 431 with minus 73 dBm, which is a signal at the input of S9, and the amplifier is connected to the power supply, is drawing 20 milliamps. So here is the control meter, which is reporting the same. So it is fired up, and we are feeding in, and we are measuring on the spectrum analyzer, and as you can see, center frequency is 431, so that is the input frequency, and the span is 10 megahertz. So we should really see if there is a band pass inside, which I doubt a bit, but we will see later. But what we can say so far is that there is no amplification at all. So there is really either an band pass inside, which is totally beneath the frequency, so it is totally off, or there is really something wrong with the amplifier, because minus 73 is really a good input signal, which should show an amplification, but we do not see nothing at all, and so therefore on this frequency nothing is ever happen. So it is more attenuator for the moment in time, but it is no amplification. So we need to look more in depth, and we have to open up and see what it is, and then hopefully we understand a bit more. Okay, so we have cracked it open, and what we can find inside, this here is, as said before, the power supply, and we have down here, maybe it's a little difficult to see, but down there is a little voltage regulator, 5 volt DC voltage regulator, and we have here our input, and we have some coils and capacities, and this pot is obviously to adjust the bias for this little down here. This here is the RF amplifier transistor. So this guy should do its job, and as we have seen, nothing really happened. So yeah, we have obviously a problem which we need to find. Okay, what we can do first is check if our 5 volt is available, which is connected to where? I don't see it for the moment in time. It is connected through here. Okay, and goes directly here on this pin. So we do not have the pin out yet of this little UHF amplifier transistor. So what we can do is we can check if we have the voltage available, and well, then we have to check it a little bit more in depth. Okay, so the analyzer is telling us that it is a junction FET, N-channel junction FET, and yeah, drain and source can't be identified, and green is gate. So it seems that this FET is okay, so there is no problem at all. So let's double check all the connections. So okay, after checking the tranny, I have soldered it back, and yeah, the funny thing is, look at this. So we have minus 55 dBm, and we are feeding. I've put it on minus 70 because it's easier to calculate. So minus 70 and minus 55. So that is really an amplification of 15 dB. So that is what we are expecting, and I presume that we had something with one of the solder points, I presume. So that is working quite nice, so we do not have a problem. We do not have a problem at all. So yeah, let's double check the amplification. I will put a power meter in between just to double check, and yeah, it seems to be okay. Yeah, let's double check with the level meter, the dBm meter. So I'm feeding minus 60, and our power meter is reporting minus, yeah, approximately minus 45. So that is exactly the same. So we have 15 dB amplification. So that means obviously that we had definitely a problem with our solder point. So now after I have resoldered it, yeah, it seems to be working. Okay, so we do not need to do anything else. It's good as it is. Okay, to double check the system and to make sure that really everything is okay, I have put the amplifier to the tracking generator, and we are now sweeping from 300 megahertz up to 500 megahertz, and our peak marker, or our marker, so that is right, is on 431 megahertz. So that is the frequency we want to have, because that is where the repeater is working on the input. Okay, but what we see is that it is really a kind of band pass response, and so our old man was right, and we are out of peak. So when we check where the peak is, it is on 393. So we have the maximum amplification on 393, and we are on, so that means I'm feeding in minus 50, so we have in reality we have really an amplification of 25 dB approximately. So going back with my marker back to 431, so here is 131, and you see we are not far as good as we are here at the peak. So what we are going to try is to tweak this this capacity here to bring our peak to the frequency we want, and therefore I start. I only have I need a strong screwdriver, and therefore I have to take a metal one, and we see when I touch it with the metal one we have a wrong curve, but that doesn't matter, because I want to turn a bit, and then we gonna check our response, and yeah, have a look. So I'm moving with my peak much closer to where we want to be. So let's go ahead in this direction. I have to be careful not to short out here my circuit. Okay, so now we have already approximately 25 dB amplification, so I try to get it a bit better. We are very close. So that is nearly where we want to be, and yeah, it is just a bit. Let me check. I mean, so we are 20, what is it, 28? Yeah, approximately we have now 28 dB amplification, and I guess that is all what we can get. So we are at the end of the range, but anyways, it doesn't matter, because we are very close to the frequency we want, and we are now at an amplification of 28, approximately 28 dB. So again, we are feeding in with minus 50, and 431 is the frequency we want to be, and we are at now at 28, so that is close to 30 dB amplification, and I would say that is great. So that is what we want to get, and that is what we need. So now it is aligned and it is working, and it can go back to our repeater, and now we will have amplification for our mobile stations. So as I said it in the beginning, that yeah, you know, we have a nice balance between our transmitter and the mobile stations which come in. So that is great, work is done, and I hope it was a bit interesting for you, even it was only a really ugly amplifier. But anyway, if you like it, please thumbs up, and catch you next time. Bye.